Hello, today I'll talk about time investment in academic computing. It is a presentation in probability and statistics for computer engineering subject. And here's Natcha limsuwan. My name is Pakorn Fudulyawajananont, and here's Patthiaon Panitanont, and here's Bhumipat Kusalatham. So basically, this study explores the impact of time spent on academic computing and preparation on university students' daily routines. As understanding these factors is important as they can affect students' productivity, punctuality, and academic success. Data was collected through a survey with 15 questions targeting university students, especially for state university. The question focused on their commuting habits, time spent on academic preparation, and related challenges. And survey responders were university students from various academic disciplines. With 21 participants, the survey was distributed online to gather the diverse perspective from students managing both commuting and academic preparation.
My name is Patthiaon Panitanont. Result of treating this topic, the data collection aims to understand the time investment of students in preparing for and commuting to academic seasons. It exposed variable factors such as the time spent on commuting, transportation costs, and the challenge students face in their daily academic commute. How we collect the data? The data was collected as online service using Google Forms. The service consists of 15 questions designed to gather both demographic information and detail related to student commuting and preparation habits. The question was split into categories. First, demographics such as age, year of study, and gender. 2. University preparing habits such as average time spent on daily preparation, weekly spending on her.
My name is Natcha, limsuwan. Third, transportation and commute information. One-way travel time to campus. Primary transportation method. Weekly transportation spending. Number of days per week attending university in person. Frequency of being late to class due to commuting issue. Both commuting preference and challenge. Preference time of day of commuting. Most fascinating aspect of commute, e.g. traffic, weather, or long-term travel. Suggested improvement of commute and preparation. With additional information, distance in kilometers of one-way commute to campus. Number of cars at 10 per week. The survey was distributed to university students, which data was collected from a total of 71 participants.
Continue with the statistical part. So let's talk about descriptive statistics. So in the nominal data, we have three data, which is gender and preferred time of commuting to campus and primary transportation methods. So in the gender part, from out of 71 participants, the majority of the participants is female, which takes place of 35 to 53.5%, which is 38 participants, and the rest 46.5% is male, which is 33 participants. The next one is the preferred time of commuting to campus. So majority of people prefer to come to campus in the afternoon, which takes place about 59.2%, which is 42 participants. And next is in the morning, which takes place 39.3%, which calculates to 28 individuals, and the rest 1.4% prefer to come in the evening, which is only 1%. And the last one is to a primary transportation method. So the biggest part that takes place is public transport. It takes place about 46.5% and calculated into 33 individuals. And then there's a private vehicle that takes place about 38%, which is 27 participants. And the lowest one is 15.5%, which is walking, calculated to 11 participants. And the next one is the most frustrating part of commuting and prepping. We choose to use a histogram because we want to compare each part to each part, not each part to all like a pie chart. And the most frustrating part that people think is waking up late for about 36 people think like that, and then the traffic, long-term travel, and weather conditions. And in the factor that would make commuting and prepping easier would be the biggest factor would be later start class, which takes place about 33 participants, and then there will be a hybrid or online learning option, which takes place about 18 participants, and less preparation needed takes place about 7 participants, and faster transportation takes place about 12 participants. So with the ordinal data part, there's 3 ordinal data parts, which are number of students by year level, number of students by day attending university per week, and frequency of late class arrival due to commuting issue per week. So in the first graph is number of students by year level. So the majority of people that do our interview is first year student, which takes place about 56 participants, and the second year they did our interview about 11 people, and the third year they did it only 1 people, and the fourth year there's 3 people do it. And the next graph is numbers of students by day attending university per week. So there's 1 people that attending 0 days at university, and the graph the majority of the people usually attending university at 5 days and 4 days a week. And the last graph is the frequency of late class arrival due to commuting issues per week. So there are 13 people that never come late to class per week, and 20 people that come late once, and 90 people who arrive late twice a week, 10 people coming late twice a week, and 5 people and 3 people next up. So let's talk about the numerical single data set, which calculates the statistical part. So let's start with time spent on prepping for universities. The null hypothesis, which is H0, known as the distribution of time spent preparing for university, follows normal distribution. And H1, the distribution of time spent preparing for university, does not follow normal distribution. And when we calculate the chi-square by using chi-square method, we get a test statistic at 72.428, which fall outside the non-rejection region at 9.488. So we reject the null hypothesis at significance level alpha at 0.05. This suggests that the distribution of time spent preparing for university doesn't follow a normal distribution. And on the top right, the blue table is the table that we use to calculate the marginal and joint PDF of the time spent prepping for university, that we get the value for rejection region. And this is a graph of frequency of time spent on university. So most people usually spend time around 25 to 25 minutes prepping for universities.
In this slide, we talk about time spent on prepping for university hypothesis testing, and data is average time spending prepared before attending university in minutes. What we want to taste, we aim to take greater students spend significantly more time than the expected 60 minutes on average preparing for university. And step 1, choose parameter. We let mu equal average time spent prepping for university. And step 2, specify null value and null hypothesis. And we let null mu equals 60 and null hypothesis is mu equals 60. Average prep time is 60 minutes. Step 3, specify alternative hypothesis. Alternative hypothesis is mu more than 60. Average prep time is, that means average prep time is greater than 60 minutes. This is an upper tail test. And step 4, compute test statistic. We compute that z equal 1.046. And step 5, use given significant level to find out the rejection region. And the rejection region is z more than or equal 1.645. Step 6, determine to reject null hypothesis or not. And we get z equal 1.046. That's lesser than 1.645. That means z doesn't fall in the rejection region. And step 7, we conclude that the average prep time is not significantly greater than 60 minutes.
This is data of one-way travel time to campus. Net of the test, H0, the distribution of one-way travel time to campus. Follow normal distribution. H1, the distribution of one-way travel time to campus does not follow normal distribution. Conclusion, the test statistic is 43.976, which fell into rejection region. Therefore, we reject the null hypothesis. This indicates that the distribution of one-way travel time to campus is not normal distribution. And the blue table here is joint and majority probability distribution. And it is histogram graph of one-way travel time to campus. The mode frequency is in range of 10 to 20 of one-way travel time to campus.
In this slide, we talk about one-way travel time to campus hypothesis testing, and the data is average time students spend commuting to campus in one direction in minutes. And what we want to take, we aim to take greater students spend significantly more than 30 minutes on average for one-way travel campus. And step 1, choose parameter. We let mu equal average one-way travel time to campus in minutes. And step 2, specify null value and null hypothesis. And we let now mu is 30 and null hypothesis is mu equal 30. That means the average travel time is 30 minutes. And step 3, specify alternative hypothesis. And alternative hypothesis is mu more than 30. That means average time is greater than 30 minutes. And this is an upper tail test. And step 4, compute test statistic, and we compute that equal 0.511. And step 5, use given significant level to find out the rejection region. And we get significant level is alpha equal 0.05, and rejection region is greater than and equal to 1.645. Step 6, determine reject null hypothesis or not. So z doesn't fall in the rejection region, therefore fail to reject null hypothesis. And step 7, we conclude that the average one-way travel time is not significantly greater than 30 minutes.
And the estimated student spending on transportation per week. Net of the test, H0, the distribution of estimated weekly spending on transportation follow normal distribution. H1, the distribution of estimated weekly spending on transportation does not follow normal distribution. Conclusion, the test statistic is 75.165 is in the rejection region greater than 18.307. We reject H0 and conclude that the distribution of estimated weekly spending on transportation is not normal. And the blue table is joint and majority probability distribution. This is histogram of estimated student spending on transportation per week. And the most frequency is in minus infinity to 50 range of estimated weekly spending on transportation.
Money that students spend per week on commuting per the goodness of which consider is distribution of spend money per week on commuting per follow model distribution. This one is the distribution of money spent per week on commuting per does not follow normal distribution. In conclusion, the test statistic is 27.5908 is greater than 18.307. So it is a reject. It means H0 is reject. The data does not follow normal distribution. In this picture is a data of giant marginal probability. So in this picture is a histogram of money that students spend per week on commuting per. You can see the range of 3,200 to 3,600 is the highest data that students spend per week.
So in the correlation, we denote in this case as R, but usually we denote as rho. So in the first pair, average daily prepping time and number of time arriving late to class due to commuting on average. So when we calculate the correlation, we got the correlation as negative 0.0382. So it suggests that those two data, if one increase, the other one will decrease. But the value of correlation is too low to be considered that two data is correlate to each other. The next one is one-way travel time and one-way travel distance. So when we calculate the correlation, we get it as 0.6727. It suggests that there's a positive correlation, which means that if one increase, the other one will increase as well. And the correlation 0.6727 is kind of strong, and we can consider it strong positive correlation. And when we follow that, we can see that it's not very scattered and it's probably tied to each other. The next one is weekly cost transport and commuting preparation. So we got RS at 0.0116, which we can suggest that it is also have a positive correlation, that if one increase, the other one will increase too, but the value is too low to be considered that two data set is correlated to each other. The last graph is current year in university and days per week of attending university. So the graph is not very tightened, but when we calculate the correlation, we get correlation as 0.44624. It indicates a positive correlation, meaning that if one data increases, the other one tends to increase as well. and the correlation 0.44 to 64 is falls into the moderate level, which is not that strong but still have some correlation to each other.